Climate change is such a complex issue.
The consequences, what we're feeling today, are a consequence of what has been happening over the past century or so.
Air pollution is the leading environmental risk factor for mortality. Globally, it kills millions of people every year.
What's pretty clear is that those effects are caused by human activity.
A lot of really important challenges, especially related to climate, will require technologies that are multi-purpose, that are adaptable to different scenarios. That, to me, is this really important area for innovation.
Societal challenges push us to innovate, to anticipate disruption, to adapt and evolve. We must break down traditional barriers and nurture alternate perspectives. What we build together today will shape our tomorrow. Science and technology offer the opportunity to fuel discovery and amplify our ingenuity. These are some of the people and ideas that are carrying us forward to emerge resilient.
First thing to solve a problem is to understand what the problem is. And so we really need that monitoring. We need to understand the current state of things and how things are changing.
Understanding kind of how satellite data can help give us that global coverage comparison between cities, comparison across countries, and then how low-cost sensors can help us downscale that to tell people things about their specific neighborhood, lets us build a better system that works.
The work that we do is helping people find the pieces that AI really can help them with today. And one of the things that was consistently a challenge was access to very large amounts of data and just having the bandwidth and the tools to process that data at a global scale. And so that really inspired us to develop a platform we call the Planetary Computer, a very large catalog of geospatial data that's publicly and freely available. Even in the era that we've had satellite imagery, asking questions like, how are glaciers changing? How is surface water and forest changing? That has required a lot of laborious annotation of imagery. Those same questions can be answered in near real time with AI. And so that's a really important category of work that we're supporting with the Planetary Computer.
A lot of these factors that shape the air pollution that people breathe, those show up in the satellite data. So we can say, there's a problem in this neighborhood, or there's a problem at this time of day. But then by pulling in land use data, or by pulling in tree canopy or other factors, you can start to see, okay, what's shaping this? What's contributing to this issue?
A vast majority of interesting and important ecosystem conservation questions now involve both what we think of as big data, satellite imagery, the kind of data we host in the Planetary Computer, and locally sourced data that conservation partners bring with them when they work on problems like this. Having access to big data really helps us make data-driven decisions about those really complicated land protection and zoning decisions that are at the heart of land policy and conservation policy.
Since the Clean Air Act in the 1970s, we've seen fine particulate matter drop by 70% in the United States. It's a huge improvement. But what researchers find when they look at those improvements is that the same neighborhoods that had the highest levels of air pollution in 1981 are the same neighborhoods that still have the highest levels today. Which means that, yes, we have done a tremendous job in reducing air pollution exposures in the United States, but we have done a much worse job at promoting equity.
We have this saying here, which is that every map of Chicago looks the same. And so if you layer on poverty levels, you get to see that south, southwest, southeast side, west side kind of being more affected. If you look at health outcomes, you'll see the same areas being highlighted. If you look at environmental justice areas, it's those same areas highlighted. And if you look at industrial corridors and where the highways are, it's those same areas.
And so that is the priority of a 21st century monitoring system. It's asking, how do you not just improve overall exposures, but how do you reduce disparities?
Some of the big questions we're wanting to answer are, what is happening in Chicago for the full city? And then what are the hotspot communities that are experiencing prolonged exposure to particulate matter, prolonged exposure to elevated air pollution levels? And why is that happening?
Project Eclipse is a deployment of air pollution sensors in Chicago.
We don't really see pollution unless it's really, really smoggy, right? Unless it's really visible to us. And so the idea was, okay, let's make pollution tangible. We started developing this air quality sensor. And the air quality sensor has a particulate sensor on it. It has 3 gas sensors on it too, and it's in the shape of a leaf.
And we said, okay, we're going to put this network where 80 of our sensors are going to be, randomly distributed across the city. And the idea is by working with the City Department of Public Health, by working with leaders of environmental justice organizations across the city, we can create a network that complements existing regulatory networks with information that can specifically be used to promote health equity and a just climate transition.
Chicago is great because we have really, really motivated community groups and really vocal voices as far as environmental justice issues. I mean, even before ELPC started air quality monitoring, there were discussions amongst communities about what's in the air around them and what can be done.
I met Tiffany at a round table about air quality in Chicago.
And the whole time I was thinking like, oh, this is awesome, this is awesome. And then they get to the rollout and timeline and I was like, hold up. I said, I believe in Project Eclipse and I think it's great. But what it's missing is community input. And I strongly, strongly urge you to reach out to the Chicago communities who have been working in this space for a really long time.
And so what she was really saying was there are voices missing in this room.
Communities, we live and breathe in these spaces that people who don't live and breathe and work in are coming and deciding what we need and what our trajectory is going to be.
We set aside 20 sensors. And for those, we're going to give mini grants, we're going to support staff time for these community organizations for them to tell us what area of their neighborhood they want to prioritize for monitoring.
In some communities, it's the trucking and traffic and just poor light synchronization. That's really affecting their air quality. In some, it's rail yards. In others, it's facilities like metal shredders and asphalt plants and shipping warehousing facilities as well. And so we can't say we're going to address air quality by doing X because that doesn't address all of the other things that are happening in other communities. The full kind of citywide network that we've built out is really allowing us to answer what's going on, where it's happening, and then the most important question, which is who is being affected by this. Publicly available data gives a community power. It allows us to speak up for ourselves and say what we need and what needs to happen. And it adds a layer of confidence that maybe didn't exist before because you saw the problem, you've lived and breathed the problem, but now we have data that illustrates that problem so you can just go in there and say exactly what you've been saying for 100 years.
That kind of information can make a huge difference, not just in what policies we implement or who we try to help, but in whether we stick with the policy, which is fundamentally what we have to do going forward.
This is the first of its kind of a full citywide localized scale monitoring. And it'll be interesting to talk to the city about what we're learning and how we're going to push together as a united front. This is really going to change things, I hope.
We want to be able to create devices that help people not only be able to monitor their local environment, but also not add pollution in general.
Sustainability needs to be a top priority, not only for the electronics industry, not only for the IT industry, but really in everything we do.
People have no idea what to do with their electronic device when it's no longer functional. Only about 20% of electronics are actually recycled. The rest are either landfilled or incinerated. A lot of these countries accept e-waste. And then because the concentration of a lot of precious metals in e-waste is so high relative to natural ore, people will try to pull out those materials in a very uncontrolled fashion. There are materials that then could either leach into the ground around a community, also potentially in their water, in their food.
Now it's time for us to think about how things are made today, with which materials they're made, how they're manufactured, and how we can increase the use of materials that are more sustainable, and also design the infrastructure so that when it gets to end of life, it's easier to deal with the waste that it generates, and in many cases, even reuse some of that.
Project Syrinx is a project targeted to thinking about how we can remake our electronics in the most sustainable fashion possible. We have a very ambitious vision of thinking about a printed circuit board in such a way that once it's created, at the end of life, it's biodegradable and environmentally benign. And so we're working on some consumer devices, and we're working on developing a printed circuit board substrate that is easier to disassemble, that we can then pull materials out.
So every time you're trying to replace something, we need to do some work to get them to the same level of performance. And so that's where the challenge comes in.
We don't have to continue using the same materials that have been used for the past 100 years. The bigger picture is really, how do we create materials that have lower environmental impacts?
People treat the environment as separate from people, right? There's nature and there's cities, for example, and these are separate. But the core insight of environmental justice is that we protect the environment because we are trying to protect people, because we are trying to make sure that our city's residents, our children, that they will have healthy lives.
I think people are tossing around resilience and equity a lot without really understanding what that means. You cannot have a resilient system if it leaves people behind.
And so what does resiliency look like going forward? I think it is kind of recognizing that instead of asking individual people to figure out how to weather storms and to figure out how to address problems, it's how do we build a society that makes it easier for everybody to get through these problems together? How do we build technology that gives people the capacity to be resilient as a community so that they don't have to do things by themselves?
If we're addressing equity and then we start to move towards a sustainable future and nobody's left behind, then and only then can we be resilient.